So my basic aim today is to give you a very broad process model on what actually happens in engineering design. We have seen yesterday what engineering design actually involves. We told we have to solve a given problem. That we have defined yesterday. How to solve a given problem? Is there a process that we have to follow? This is a very interesting question. Please recall the discussion we had yesterday. We were in a dilemma to decide whether engineering should be considered more as a science or as an art. Now if you say science, that means science always has an established procedure. You have to just follow the procedure. Art inherently does not believe in established procedure. Breaking the existing norms is quite normal in arts. Now, see what we are saying today. Today we are saying that we will define a broad process for engineering design, meaning I am establishing a standard process. So what am I claiming here? I am claiming that there is some process, you have to follow it, meaning I am inching towards defining engineering as a science. Now you may ask the question, sir, we will follow the process which you say, will you guarantee a success? Scientific experiments are done like this. You follow a standard procedure, you will get same results. Recall what we said yesterday, take Newton's ring. You do, I do, follow the procedure, we'll get the same result. Is it same in engineering design? That is what we can't guarantee. That is where we flip-flop our argument and say, see, I cannot guarantee you, but at least I can guarantee that if you follow this process, since many people have followed the process and they were successful, maybe you will be successful. I am not guaranteeing. I am not ready to give a blank check saying that if you follow the procedure you will become successful. It's not as simple as that. So having this in your mind, and one more caution before we start, nothing happens as we discuss here. We will define a very clean process, but rarely do people follow this. Rarely. So don't get over obsessed with following this process. Consider this more as a guideline which you may follow. Fine? Among the various process models in engineering design, Ken Hurst in his textbook speaks about two different models. There are various models. What I am giving you is a alternate model of Pug model which is given in the textbook. Pug, the genius engineer who came in the 20th century, defined a well-known engineering design process which is given in the textbook. I am altering the same to suit my requirements here. So in a sense that this is altered Pug's model of engineering design. Fine? Let us start like this. Well, any process in this world, any process, irrespective of what you are talking about, basically has only three components. Only three. What are they? Any system in this world has basically three components. What? Input, process, output. You take any system. In computers also you started like this because computer is also a system. Take any process, any system in this world, it necessarily has only three. Take any machine in this world, any machine. Fan, it has an input, it has a process, it gives output. Anything in this world has only three basic components. Okay? Input, process, output. We will try to fill the things as and when we have to fit into a particular context. The context today is engineering design. So I will alter this basic model to suit engineering design, taking Pug's concept. Let us start. What is the core of engineering design? What do we do? There is a problem. We take problem as input. Then we have to process the problem. Then give a solution. That is the basic model. Problem is input. Somehow we have to solve the problem, the process. Then we have to give a solution. Is this clear? That is the first level of identifying thing. How do we improve upon that? The problem. When I say the problem, how do I define that problem? Where do I get that problem from? How can I identify a problem? Puck says the necessary input for engineering design is market. The activity is called market survey. What is market survey? Ideally, market survey is identifying the gap between what customer actually wants and what is available today in the market. The gap study. See, most of us, we don't buy things because we actually want it. Well, let me not go too much into this topic, but let me just say that every company basically today does not sell product or service. It sells us an aspiration, a dream. We buy the dream. In turn, we buy a product or a service. Fair and lovely. It's not a product, it's a dream. They're selling you a dream. And people who want to buy the dream will buy that product. So, market study in a sense is nothing but identifying that gap. There is something in the market which is currently available, but what customer wants is something else. If you identify that gap, you can fit in there. That is market survey. So, identifying, studying the market through a decent analysis process called as market survey, identifying that gap is what we call as problem specification. You identify the possible problem that you may try to solve. Right? So that is input for us. There is market which we... Okay, now I have done a market survey. I know there is something missing what customer wants. Now what? Out of various things that you may possibly do, you pick one problem. Once you have picked the problem, there are basically only three things to do. Well, first you have to answer the question, what? What is that you are going to do? More technically, that is called as specification. Specification is nothing but telling in no nonsense terms what you are trying to do. What? Okay? Identify the market gap, then specifically answer the question what. It is not a storytelling, as we will see in our next lectures, but precisely telling that this is what you are going to deliver or this is what you are going to solve. Identifying the problem clearly. Understand the problem. That is the first step. Then the next step is most crucial step. Combined together, I call it concept design. The idea is this. Once you know what of a problem, the next step is to ask how. How will I solve it? Again, this is where the basic engineering mindset should come. We are not telling that since there is a problem, you directly solve it using approach number one. No. The ideal way to solve problems in engineering is this. Once you have identified the problem, you have to give as many solutions as you can. Generate multiple solutions. After that, using some criteria, you select which is the most optimal solution. In engineering, there is a very favorite term, very favorite saying. One solution is no solution. You may be wondering, have you gone through computing course, introductory computing course? Have you completed? Okay, you may be wondering why there are so many sorting algorithms. There is bubble sort, merge sort, heap sort. How many you know? 5, 6?
There are some 25 also.
Donald Knuth's book, The Art of Computer Programming, lists more than 100 sorting routines. Why do we have to have so many sorting routines? Simply because every sorting routine is not suitable for a purpose. Engineering in our field is not knowing how to write bubble sort. You should be a fool if you know how to write a bubble sort. Nobody writes bubble sort. It's already available. It's like a piece. Your success comes when you know where and how to apply bubble sort. For example, let me give you a very simple problem. Let me say that I will call you to my cabin. There are blue books, 180 blue books in a random order. I will ask you to sort it. Can you apply any technique that you have studied and tell me which sorting method is good? That is judgment, that is engineering. How many ways are there to build a bridge? If there are two ends like this, you can build a bridge like this without any pillars, or bridge with pillars, or two sides hanging bridge. Which is better? That is engineering. Selecting a solution which we call as the optimal solution among the alternates is engineering. So the heart of this discussion is this. That is why I say engineering is nothing but design. You populate the solution space, generate as many solutions as you can, then select the most appropriate solution. That judgment is engineering. Okay? So you have asked the question what, then now you have asked how, you have answered them. Among the various possible solutions, you have selected one solution. Then you have to develop the design completely. See, you just give a random choice, select one, then complete design has to be developed. The complete solution has to be developed. After that, well, design is on paper. It's on paper. You have to actually build the solution. Okay? So, you started with the market gap. You have understood what you have to do. How should you do? Select the optimal solution. Actually implement it. Actually implement it. Then, what is output? Output is a solution, the product or the service. The act, Puck says, is selling. I am okay with that. Right? The product is sold to the market. All the market consideration, marketing and other things, advertising, promotion, fixing the price. There are various issues. Let me call it, using the consolidated term, sell. This in broad are the activities in engineering design. So what are we going to do from now onwards? Is actually see each aspect in detail. Well, are you clear? This thing should be there in your mind always. This is something which should become inherent part of your thinking. If you ask me why we have introduced this subject, we have introduced this subject because we want you to think like this. Given a problem, we want you to engage in a systematic thinking. This is how we should think. You can get it only by practice. No amount of rote learning can help you in this. Well, let me just add my thoughts on this. This is a basic model. I want to improve this model. I am improving this model using two concepts. Let me introduce those concepts like this. See, this is a common framework for anything, okay? Any system you can develop it like this. For example, fan we can take, but it will be, okay, fan. Fan, simple fan. How? There is input, there is process, and it gives some output. We have understood. How to improve the working of fan? How have we improved the working of fan? Apart from input, process, output, have you identified any other component which makes this efficient?
Sir, the blades are slanted.
No, don't worry about blades and motor speed and other things. Input is current, process is the motor working, output is the cool air that we get. Beyond these three, is there any component that you see which has improved the working of fan? Huh? No, this fan. There is something here which is added to the efficiency of the design of fan. No, fan only. Just see. Regulator. Exactly. In our original discussion, there was no regulator. Input was current, direct. Fan, output. How did we improve this design? Regulator. Correct? I call it control. Any system should have a control. It's not mandatory. Please see. The fan can work without regulator also. But having a regulator improves. That is, I introduce one more component to this three-part design. I call it control. Okay? This control component, if you add to any system, the systems become much more efficient. The control component has the ability to control either the input or the process or the output. It can control anything. You take any system in this world, it will have a control component. Take your stove. It has the knob which will increase or decrease the speed. Take anything. Take your bike, take the car, anything in this world, it will have a control component. It improves the design. One more component which I want to add is again very intuitive. Okay, forget fans and take AC. Take AC. What is that which is there in AC and not in fan which makes AC efficient? Huh?
So we can control the temperature. We can control the temperature.
More than that. More than that. Huh? Yeah, that is equivalent to knob. Something more. Huh? What else is there? There is a knob which you can control. That thermostat is always there. What else is there? Huh? What? An intelligent AC, an intelligent washing machine. How do you give intelligence to machines?
So they control the temperature on their own.
Exactly. How?
So using the thermostat, they.
How?
It is the requirement.
Can you do some alteration in this diagram to show that? Input, output, process. How can we improve this using that concept? What is that concept?
Virtual intelligence.
Yeah, how? It's very simple. If you give whatever comes as the output, right? If you give a feedback loop, the system becomes much more important. What happens in AC? There is a sensor which senses the temperature of the room. Depending on that, it gives back the signal to the input and the processing unit saying that you either increase or decrease. Your washing machine, your refrigerator, which are all called intelligent today, works with this basic principle. How do companies improve their performance? Once I sell my product, I do customer satisfaction survey. And I take it as an input again to improve my product. The discussion is same. Are you getting the point? So, what am I telling you is that this basic idea of design can be improved upon by adding two additional components, control and feedback. Totally using these 5 components, input, process, output, control, feedback, you will get a complete idea of what is involved in engineering design. From now onwards, we have only one job to do. Understand each of these things in detail from software engineering perspective. I am not going to deal with mechanical engineering perspective. Let me add very few initial details regarding this. How is this activity done in software engineering? It is very, very difficult to do this activity. In fact, the biggest failure of our industry, let me confess, is this. Why? Mainly because unlike in mechanical engineering, where all these things are mostly automated. How do you do the design? There is AutoCAD. How does a civil engineer design? He has his tools. How does a chemical engineer do it? He has a plant manufacturing handbook, he just sees that, builds the design, fine. We don't have that. In that sense, we are falling short of all other traditional engineering brothers, however they practice their trade. There has been consistent efforts. If you look back, starting from 1968 till now, there has been various process models identified. We call it process models, okay? In our field, we call this as process models. What Ken Hurst calls as engineering design model, we in our language, we call it process model. More clearly, it is called SDLC. Software Development Lifecycle Models, SDLC. There has been virtually hundreds of SDLCs defined. I am not going to give you all the details. In the next lectures, we'll see one or two SDLCs. Try to understand. But let's not forget that things are not simple as they seem here. They don't go so methodically. For example, after I do specification, I do concept design. This one-way arrow, it's not consistent. If I am not satisfied with my concept design, I'll come back to do specification. You should understand that. It is not as methodical as I write here, and it is not possible for us to do like this. But anyway, let us hope to follow this procedure as far as possible. Did you get the point? This is what we are going to do. This is engineering design, if you want an actual idea. So from next class we'll be taking each issue in detail and discuss various aspects.